Okay, so part 5 was supposed to be the last part for exam preparation course in April. So the next part was meant to be in May, or even June. But recently, a few hours ago, I've received a bunch of questions. Actually, there are more than 40 questions, 45 up to 46 questions. When I review them, most of them are from the old CCNA question, but some guys says that you might also see them in the new CCNA exam. You will find them very simple, actually, and we will start just working on them right now. So more than 40 questions, of course, will not be added in one or explained or discussed in one single video, because this you can see that after I even finished chapter 4, I've shaved myself by myself because of quarantine, no barbers outside. Anyway, so what I was talking about is that 40 questions or plus cannot be recorded in a single video, so this will be 2 videos, meaning that in April we'll have even part 5 and part 6. So for part 5, without wasting time, let's start discussing again, and let's see we will solve today. Okay, is everything working? No, everything is not working. We will need to restart our tablet. Yep. Dark? No. Okay. Which option about JSON is true? It uses predefined tags or angle brackets. No angle brackets at all. To delimit markup text. No, that was you see in the format. Used to describe structured data that includes arrays. Yes, because it does describe structured data, and that structured data are APIs. Also, they does include arrays because we have seen some examples. Okay, so far we are good, but used for storing information. Not quite correct, no. Similar to HTML, it's more verbose than XML. What does verbose mean? What does the word verbose mean? I'm sorry, I did not translate that because for my English language, this is the first time I see it. Maybe most of you will know what that means, but just 1 minute. That's why Cisco does give us, oh, extended or more complicated. No, definitely not. It's less than XML, and you have seen a comparison between that in almost the last video of the English course, when we have established a lab and compared between JSON and XML and converted XML to JSON. Anyway, so B will be correct. Okay, jump in. 104. Which type of address is the public address of the NAT of a NAT device? Show IP NAT translations. After performing a NAT will show you all the translations that you have done so far, and it will be like an inside local. This will be your private IP address of the organization. Inside global, this will be the public IP address of your organization. Outside local will be the private IP address of the server of or the destination that you are talking about, which is not from your organization, of course. It's through the internet because you are using NAT. And there is also outside global, the public IP address of that google.com, Facebook, whatever you're trying to talk about. So which type of address is the public IP address of a NAT device? Okay, publics definitely will be global. It's either inside global, my public, outside global, the other guy's public. But since you are talking about a device, then it should be mine. And mine will be inside global, so it should be C. If you're talking about this one, there is there is nothing called inside public. There is nothing called outside public. This is called now giving 6 options for to only for choose one. Definitely anything, I'm sorry, anything local is no. So outside global is the destination, inside global is mine, and since he's mentioning a NAT device, then it's my edge router. Okay, so I will go definitely C will be correct for that. Okay, this is 104. 105. This one I had to use 2 pages to write or type all these commands. Refer to the exhibit, and the exhibit is about 2 switches connected using 2 ports: fast ethernet 01 connected to fast ethernet 01, fast ethernet 02 connected to fast ethernet 02. A network administrator is configuring an ether channel between switch 1 and 2. I can see that. Switch 1 configuration is showing, which is this one. This is the SW1 and this is the config of both interfaces. What is the correct config for the other one? Okay, should be simple. Switch 1 has two interfaces. Okay, interface fast Ethernet 01, channel group 1 created a channel group mode auto. Okay, so we have auto, and auto comes from port aggregation protocol, which is a Cisco proprietary, and it's not an open standard protocol, and Cisco even removed that from the config, but we have mentioned the modes back in chapter 2 and in chapter 6, all maybe also in the wireless. So LACP uses active and passive. PACP, which is for Cisco devices, only uses auto and desirable. Auto is like a passive. Desirable, he wants to, he wish to talk, to start a chat, a communication. So desirable is like an active. So this guy is passive for fast Ethernet 01. Okay, the port is encapsulated on 1Q and thus it's trunk. Okay, I agree. Fast Ethernet 02, the same config, channel group 1, mode auto. So this should work completely from this end, from switch 1 end, but from switch 2, what will work is, so this guy is using PACP. This one is also should use PACP, definitely. So on will not work. Active, which is of LACP, will not work. Passive, which is also of LACP, will not work. So it's either auto or desirable, which are both from PACP. Since auto is like desirable, he's a silent, he's a shy, he'll never talk, will never start a chat, will never start a communication, will never tell the girl that he loves in college or whatever, or even in work maybe. So the other side should start communication. So the other side must be desirable. So it's either both devices are desirable, both of them start a communication, establish a chat, or one of them, at least one of them is desirable. So since switch 1 is auto, switch 2 must be desirable. So we will need a config saying that both fast Ethernet 01 and 02 are configured for channel group 1 mode desirable, and also both of them should be trunk. Okay, so let's go for the possibilities. A is active, never. B is auto, and since A is switch 1 is auto, I'm sorry, by the way, these possibilities are the config on switch 2, which config is correct. And B is auto, and this will definitely not work. So let's see for C and D. Okay, so go away, scary spider. Okay, go back here. C says mode desirable. Okay, I agree so far. Switchboard trunk encapsulation.1q and trunk. Okay, half correct. Interface fast Ethernet 02. Also channel group 1 mode desirable. Trunk. Exactly. That's it. C is good. And this one is passive, so it's like B. Okay, so C will be good. We'll be also configuring switch 2 to become a PACP, creating ether channel or a port channel interface, and it will communicate. Okay, question 106. Refer to the exhibit. The exhibit is about two switches. Each one of them is connected to two PCs, PC for VLAN 1, PC for VLAN 2. This link between them definitely will be trunk because carrying two VLANs. And switch 2 is also connected to a PC on VLAN 1, another PC on VLAN 2. So a frame on VLAN 1, on switch 1, so this is switch 1 and this is VLAN 1. So a frame is coming this way, heading to the switch on fast Ethernet 03, is sent to switch 2, okay, where the frame is received on VLAN 2. So the frame should travel this way. This is an access port for VLAN 1, and egress from this interface, which should be trunk, also should be trunk, and will egress again from this interface, which should be access for VLAN 2. Okay, what causes which behavior? I'm sorry. Refer to the exhibit. A frame on VLAN 1 or switch 1 is sent to switch 2 where the frame is received on VLAN 2. Oh, so you are saying that it should not? Yes, it should not. I'm sorry, because there is no router here. So VLAN 1 should not see VLAN 2 at all, because they are separated, and there is no router or a multi-layer switch to do an inter-VLAN connectivity between them, either by a router on a stick or switch virtual interface. So VLAN 1, whenever a frame comes from VLAN 1 and travels to switch 2, it should only contact the PC of VLAN 1 on this other switch. So why it went this way? Let's see. By the way, there is a config on switch 1 show interface trunk, says only fast Ethernet 01 is the trunk. I agree. On switch 2 show interface trunk, says that only fast Ethernet 01 is the trunk. I agree also. And both of them are passing VLAN 1 and 2. I agree, so no problem at all in the config shown here. But the possibility is either a trunk mode mismatch, no, this will never affect it because the frame passed anyway, allowing only VLAN 2 on the destination. No. Native VLAN mismatch. How can I know? I cannot troubleshoot that. Native VLAN by default is VLAN 1 because VLAN 1 is the default VLAN and VLAN 1 is also native VLAN. We can change the native VLAN to make it. Oh, I'm sorry, there it is. Native VLAN or switch 1 is VLAN 1. Native VLAN on switch 2 is VLAN 2. So there is a mismatch. But will that cause this problem? Because when what native VLAN does is native VLAN will cross a trunk interface and tagged. So it does not have a tag for a VLAN ID in the frame body. So that will make it. Okay, switch 1. It's 1 minute. So switch 1 will receive a frame from this PC on VLAN 1, and since VLAN 1 is a native VLAN for switch 1, then it will enter switch 1, exit switch 1 and tagged. So it will exit this interface not carrying a tag of VLAN X, whatever VLAN. So when this switch receives it, it sees it as VLANless. It has no VLAN, so it's untagged. It has no tag, so that's why it will pass it to VLAN 2. So yes, C will be correct because the VLANs that do not correspond to a unique IP subnet. No, we are already separating broadcast domains. Leave this one. Okay, so this one allowing only VLAN 2 on the destination. No, because that will drop it. C will work. Okay, because VLAN 1 will be a joker for switch 2. It will have no specific identity. That's why it will pass to VLAN 2 there. Okay, so that will be C. Okay, 107. What are two enhancements that OSPF v3 supports over OSPF v2? OSPF v3, the only difference between OSPF v3 and OSPF v2 generally is that OSPF v3 was only developed for IPv6, while the classic OSPF v2 that we know, which is only OSPF, is the old guy for for IPv4. So A, it requires the use of ARP. No, not an OSPF v3. B, it can support multiple IPv6 subnet on a single link. Yes, there is such thing, and I believe that I did a lab for that in my CCNP before, and we will do that definitely in CCNP Enterprise course. C, it supports up to 2 instances of OSPF v3 over a common link. Not sure. D, okay, it says choose 2. There should be an E actually here. What's missing? Let's hope that we will find 2 correct answers out of these 4, because this one is incorrect, this one I'm not sure about, and D says that it routes over links rather than over networks. This one is definitely correct. Once you do a lab, an OSPF, and you have inside a router like some interfaces, you will not have the same command of OSPF v2 where it says like OSPF1 network XXX wildcard max XXX etc area 0. This will not be this way. You will enter this interface, because instead of typing the entire wildcard mask and interface like this big, an IP address of IPv6, This will be a big headache to advertise just 2 or 3 networks inside the router. The simple way is to enter this fast Ethernet 01 here and says OSPF v3. That's it. Okay, it's a short command for enabling OSPF v3. That's it. Whatever this interface carries an IPv6 address, this IPv6 address and its network will be included and advertised for OSPF v3 with the same address ID and wildcard mask, etc. automatically. So it will be much simpler. Okay, so this one is definitely correct, and also this one is correct because you can add multiple, like a link local IP address and another IP address that you will specify later, private IPv6 address, and you will use both of them. Okay, so B and D are good. I have no idea what E might be in the exam if you face such question, but B and D are definitely correct. Okay, 108, 108. Which option is a valid IPv6 address? What makes an address a valid IPv6 address? That will be an 8 parts address separated by a colon each. Each one of them have 4 digits, and they can have a shortcutted by using double colon only to shortcut some zeros. So the first one, only single double colon can be used in the entire IPv6 address. So A says that 2001, okay, colon zeros, okay, colon 13OF, double colon, maybe some zeros are here, this one, and another double colon. Only a single double colon is allowed. The other one says that B 2002, numbers, okay, I agree. Since there are only 2 numbers here, it means that there are 2 zeros on the left, so it's 0061. You can write it this way. And this guy is correct, this guy is correct. So I can see there is no double colons here. Yet 1, 2, 3, 4, 5, 6. It should be 8. I'm sorry. C says FEC0 A B C D W X Y Z. Who is W X Y and Z? It's a hexadecimal language. It starts from 0, yes, up to 9, and there from A up to F. So from G to Z, this is not a hexadecimal language. This is the English language, definitely. Let's hope that this guy will work. 2004 colon 1. Colon 1 means this way. 25A4 886F, a double colon 1. So this is 1, 2, 3, 4, 5, and the double colon is shortcutting 3 of this guy. 3 quarters or 3 parts that are including, so it's shortcutted. It's shortcutting 12-0 inside it. So this one is definitely correct, and these guys are joke. Okay, so they will never be correct. Okay. Okay, question 109. Choose 3 and sorry. Which 3 are characteristics of an IPv6 anycast address? I did talk about message types in chapter 1, which was there is a unicast message which has only one destination to go to, like a ping goes only to this guy, this destination. A multicast a multicast message. This is an L. The multicast goes from one to a group based on a joiner between them and a rendezvous point. And even in OSPF there is a multicast messages like 204, 005. A broadcast address or a broadcast message goes to everyone by force, and this is very annoying. And IPv6 does not support broadcast. This is awesome. And instead of broadcast, IPv6 supports something called anycast, which is 1 to the nearest. This is like you are sitting, like where I'm sitting right now in Baghdad, in Iraq. So if I wanted to use like google.com, like, or youtube.com, YouTube or Google themselves might be using anycast with IPv6. So they will have one of their servers in UAE, another one like in Turkey, a third one in Frankfurt, Germany, and maybe the fourth one would be in USA. The idea here is that all of them are connected almost together because this is Google's network. I have no idea how it's connected actually. But what's happening is that by using Anycast, IPv6 Anycast, we can have all of these servers carrying the same IPv6 address without a duplication. What will happen, or the benefit is that is when I want to go like to for youtube.com, I know youtube.com has the IPv6 address of like 2001 etc whatever. This IP address before IPv6 was only in this server, so I would have to travel all the world reaching USA. Right now my message will travel starting like from my ISP going through all of this network. The nearest server that's carrying this IP address will be the one who will reply to me, which might be in UAE or maybe even in Turkey, but both of them are much nearest than Frankfurt or even USA. So this is the big benefit of IPv6 Anycast, I'm sorry, message, not the Unicast, the Anycast message. So three characteristics would be, it is a one-to-many, never, this is not a one-to-many communication, that would be a multicast. It's a one to the nearest, this is what I said. It's any to many, there is no such IP address that's got a message that said any to many. It must start from one, so it's one to someone. It's a unique IPv6 address for each device in the group. No, it's common between them, okay, just like I mentioned. So that leaves us only two, and both of them should be correct if we got the idea good. The same address for multiple devices in the group. This is what I have just mentioned. Thank you. So I understand IPv6 correctly. So does the exam says. And F, delivery of packets to the group interface that is closest to the sending device. Okay, this is the idea of one to the nearest. So this is how IPv6 Anycast address or message works. Okay, so that would be BENF. Okay, 110 would be a drag and drop. Okay, refer to the exhibit. This is the exhibit. Drag and drop the routing table components on the left into the corresponding letter from the right. Not all options to be used. Okay, there is A, B, C, D, and E. Okay, so that will be, oh, so you mean you want me to know the legend of the routing table? That's why there is a legend in the routing table, because it will tell me what the shortcuts refers to. It's not me who should memorize them. So there is A, B, C, D, and E. Okay, that would be unfortunate because I cannot memorize those right now. There is an administrative distance, metric, next hop, outbound interface, router source, subnet mask, and timestamp. That will make them 7. What we need are actually only 5. So only 5 of them do match these letters, these shortcuts on the right. So let me see 1 minute. What I will do is that I will actually ask for an image for routing table. It would be unfortunate if I got to the exam without memorizing those, because this is such question will make me really confused in the exam, saying that do I really have to memorize those? So the routing table, all of these routing tables, they do not show any legend. Okay, so C stands for connected. These are the routing these are the routing protocols. Okay, so now I did not catch the idea because this is a routing table, and just like I remember, C here stands for connected and D for EIGRP. and those are the routing protocol shortcuts. So what would such question mean? Share the screen 1 minute. Okay, let's head into this and hopefully we will find something. No, definitely not. Okay, let me read this one. Drag and drop the routing table components into the corresponding letter. Okay, 1 minute. What does corresponding letter means? Okay, so A will be for AD, administrative distance. B would be for the bound, outbound. C would be for the metric, like cost. D would be for a router source. What I'm saying? What am I saying? Okay, 1 minute. Let me ask for the help. Okay, just 1 minute. Actually, I tried to just to explain what's really needed for that. 1 minute, I'm sorry. 110. I don't want to Google that. I don't want to have some already printed answers. We will need to discuss that. So what I will do is that actually right now I will ask you if one of you just has have an idea about what the corresponding letter should be. Okay, so let's see if you have any ideas, and we will agree on a correct answers. I will add the correct answers to the description of this video below. Okay, so just I will hope for that, because I don't want like A for AD or router source, B for metric, C for next hop, and we need to understand why. What does this exam means actually? What does this question, I'm sorry, means? Okay, so let's jump into another question, and I hope that we will reach something. I will search the internet for that too. I will not answer it right now. We need to search it furthermore. Okay. Okay, so let's go for question 111. Which two statements describe characteristics of IPv6 unicast addressing? We have just talked about that 2 questions ago. A, its global addresses start with the global. I'm sorry. The addressing, the unicast addressing, which is the IPv6 addresses that we know. Okay, not the multicast, but the unicast. A, global addresses starts with 2000:/3. This is what I've talked about, one of the types in chapter 1. B, link local, that starts with FE00, or C, link local, that starts with FF. Link local does not start with FF, and I believe it does not have this subnet mask, so both of them are incorrect addresses. D, there is only one loopback address, and it's : 1. By default, yes, but we can add more. 1 minute. E, if a global address is assigned to an interface, then that is the only allowable address for the interface. Is that correct? No, this is not correct, because we still can add the link local for some internal negotiation, I believe. So D will be correct, because there is an internal default loopback that's called : 1, and that means zeros and in the end 1. This is the loopback 1 of IPv6, the loopback address of IPv6. So A and D, both of them are correct regarding some types of the IPv6 address. 112. What is the alternative notation for the IPv6 address? Right now we had like 3. Okay, so the previous IPv6 address question and this one, so 111 and 112, both of them are from the old CCNA 200.125, but you might still find them because these are the IPv6 questions, what they can ask, just like the subnetting and address range, etc. of IPv4. These are the questions of IPv6. And even Juniper and Huawei exam, you'll find these same questions for IPv4 and IPv6, because This is all what those addresses are about. Okay, so B514 colon address colon this one, this one, this one. Good. Colon this guy, this one. Okay, so 1 2 3 4 5 6 7 8. This is correct. So one of these must also equal it. So this one will be B4514 colon, okay, the same 8 to C3 colon 009. So this one is not there, not here actually, but it's a single colon, not a double colon, so you have no right to remove the zeros. B starts again the same first part, the second part, a double colon, and then again, so far we are good. And then there is an EC7A and an EC72, and those zeros are disappeared here. Not even a single zero is replacing them, so this will be incorrect because this guy will be have to remove and become here because this double colon will inject like 12 zeros to complete the 8 parts. So it definitely will be a different address. C says the same beginning and no double colon for removing these guys, so you are definitely incorrect. And D is our last hope. B 514 8 2C3 double colon for these guys, two guys, and then this one over here EC7A a 0 which will be extended to 4 zeros. Actually it will not be extended to 4 zeros, but automatically since there is a digit here. Okay, so what will the system does is that it will add some zeros on its left until it becomes a 4-digit part, and finally the EC72. So this one will definitely be acceptable as an IPv6 valid address. Question 113, more IPv6 questions. Also, which one is valid? Just like 5 questions we had before. 2001 0db8 zeros 1305 0 zeros 08G hexadecimal language ends with F, so no GHIJK, never, never, never. Okay, the other one will be 2001 DB8013OH, no H. This is not even an hexadecimal language. These two are not even hexadecimal language addresses. Not just the IPv6 address, but they are not from the hexadecimal word at all. Third answer will be 2031 double colon 13OF double colon, no double colons. You will have to move that from your dictionary. The final one will be 2031 colon 10, that means 4 zeros as well. 13OF, a double colon. Okay, 9C0 means also one guy will be injected on the left. 876A 13OB, definitely correct. Okay, so that will make it 1 part 2 3 4 5 6 7 and 8 will be injected by the system to this double colon as 8 zeros. Okay, so question 114 will be which two features of IPv6, which two are features of IPv6? Just like I've mentioned before, broadcast is definitely not an IPv6 something. So anycast is just like before, multicast is just like before. It does not support broadcast. Instead, it comes with an with an anycast, and there is also a unicast. So it's unicast, anycast, multicast. That's it. No podcast, no allcast. Okay, only these two. And if it was answer 3, then will definitely there be a unicast also. 115 will be which command enables IPv6 forwarding on a Cisco router. I had an IPv6 static route lab back in chapter 3. So for my routers in order to enable IPv6 routing, I have entered the command IPv6 unicast routing first, and then I have configured the IPv6 static route in order for the IPv6 addresses and protocols to start forwarding and installed in the routing table. So that will be IPv6 unicast routing. This command must be enabled. After that, you'll start like enabling OSPF v3, EIGRPv6, BGPv6, and definitely IPv6 static route. Too much IPv6. Okay, this one should be simple and also from the old CCNA. Which IPv6 address is the equivalent to the IPv4 loopback? I just mentioned that a few minutes ago, and that was double colon 1, a dozen of more than a dozen of zeros, and the one in the end will give me the loopback address of IPv6. So this one is a double colon and 1. Double colon of nothing means all zeros. This is not a valid address. This is the global guy, and this one is also not valid for the loopback. Okay, so this is the loopback address, the default loopback address of IPv4. You can add more, and this is the default IPv6 address, and you can add even more later. Okay, primary, secondary, etc. Okay, even more IPv6. Okay, let's see. In which two formats can the IPv6 address this guy be rewritten or written again? So A says that FD15 colon 0db8, okay, zeros, zeros, so far we agree. 700, just 10 on the left, this can be shortcutted or removed, I agree. Some zeros on the left have been removed here, so far we are good. 400F, okay, and 572B is good. This one is correct. B says FD15, okay, which is this one, and then a double colon for DB8. How many zeros will be there? If you mean this single zero, then you are definitely incorrect, and one of the guys did remind me of that in the chapter 1 about some double zeros to be removed from or hidden from the left. Okay, so this one will definitely be incorrect, and there is also a double colon here, so remove it. C says FD15 colon db8, so the zero on the left is removed, no problem, and then zeros become 10, okay, and then a double colon for 700, so only this part will be replaced by a double colon. So far we are good. Later there will be 700, 700, and the zero on the left will be automatically injected. A 3, no zeros, since they are on the left, will be injected. 400F, 4F, no, you cannot manipulate from the inside of a part, either the left or the right, depending on the mechanism. Okay, D, FD15 is good, 0db8 is good, a colon, then 7, so that will be colon for these guys, and 7 only should stand for this guy. It will not stand for this guy, definitely. So this will be a different address. One last thing, one last try. FD15 db8 instead of 0db8, 0 on the left can be removed. A double colon and there suddenly is 7. So double colon is removing these two. 700 will be a replacement for 0700. I agree. A 3 with no zeros because they are on the left. 400F and 572B. Thank you, finally. Okay, this is really annoying. This takes time in the exam, but you should guarantee its score. You must never lose scores of such questions. Okay. Question 118. Refer to the exhibit the MAC address table. This is the MAC address table. Okay, yeah, this one. Okay, let's see. There's a source MAC, destination MAC. Oh, I'm sorry. This is the MAC address table, which is having some interfaces along with their addresses from this guy. Okay, showing it's in its entirety. Yeah, the Ethernet frame that's showing arrives at the switch. There is an Ethernet frame coming from the source of zeros A's, so it's from this PC on fast Ethernet 00, and this guy is not added here. Okay, so it's coming from this interface for the first time. What two operations will the switch perform when it receives this frame? Okay, so we have two cases. Case number one, when some frame wants to reach a MAC address that's not added in the MAC address table. So the switch will have no idea where to forward that frame, so it will flood it for all the interfaces, the broadcast flooding, okay, for all the interfaces except for the interface that the frame came from. So this is when a switch wants to forward the frame to an unknown destination. But when a switch receives a frame from a MAC that has not been added, so the source MAC is coming for the first time in the switch life. So the first thing that will happen, simply the switch will only edit its MAC address table and add this new entity, yeah, which is zeros and A's. The MAC address here will add it and also will type FA00 as an interface. Okay, so this is something very predictable, number one. But the problem is that just before I read these possibilities from the exhibit, I can see that this PC that has this source address is sending actually a broadcast frame, because the destination MAC is FFFFF 12F, which in binary equals ones, equals all ones forever. Okay, not forever, for a limited amount actually, but this is the broadcast. So what will happen is that, number one, this switch will add zeros A's, the MAC address of PCA, and its table with the interface of FA00. And behavior number two, just before I read those, this is logical behavior. Behavior number two for the switch, that a flooding will happen. So this frame will be flooded out of 01 and 02, not out of 00, because it was received from fast Ethernet 00, but will be flooded to these two interfaces. So let's see the possibilities, 6 possibilities. We need to choose only 2. A, the switch will not forward the frame with the destination MAC address. No, frames will be forwarded. This frame will be forwarded. The frame will be forwarded out of all the ports on the switch, not out of all of them, but out of FA0 and 2, except for FA00. Will not be forwarded out of it. The MAC address of Fs will be added to the MAC address table. The destination will not be added to a MAC address table, source only. The frame will be forwarded out of all the active ports except for FA00. This is what I was talking about regarding the behavior of the flooding. The MAC address of this guy, zeros A's, will be added to the table definitely, since it's a source MAC address and it's a valid MAC address. So we got our 2 valid replies, and finally the frame will be forwarded out of 00 and 01 only. This will never happens for this frame. Okay, so this will be D and E. Okay, and I believe I talked in a good amount about these behaviors back in the beginning of chapter 2. Refer to the exhibit. Which switch in this config becomes the root? What makes me a root bridge? 2 things. I have the lower root. What was called? It was called the root. I'm sorry. The big one was containing of the root priority, the bridge priority. Okay, it was called the bridge ID. Yeah, the one with the lower or the lowest bridge ID wins and becomes the root, and bridge ID is a logical and not really a real or a address or an ID, because it consists of the MAC address of a switch and its priority. So the lower the priority will wins. If all the priorities are equal, then the lower MAC will win. So based on the exhibit, no priorities are mentioned here, so just like to make it hard for me. Okay, I will have to choose then the lower MAC address. Start with switch 1. This will be 0C0E15. Here is 0C0E15. Seems both guys are from the same manufacturer. They have the same first half MAC. What's 0? 0C0E15, the same thing. 0C0E15. So all of these 4 are manufactured by the same company. So AA, BBCC, this is the big one. All of them are letters. AABB, and C is much bigger than this one. So comparing to this one, this will be okay lower. I'm sorry, this will be lower. So this guy so far is good. okay, because C's are bigger when we want a lower one. And between these two guys, if they fall together, there will be an A1, 1A, the same result. B3, 3C, and 9D. So there is a C and D here. This one is very big. Okay, so they are eliminated. Two guys will battle here. Switch 2 and switch 4. AA is much bigger than A1. Okay, so this part is winning. AA is smaller than B3. And there is a 19 which is much smaller than BB. So this one is bigger here, a bit of smaller here, but this one is much smaller. So this one will win, and that makes it switch 4. Yep, that should be it. That should be this way. Should be switch 4. Yep, and if you really have time and you really wanted to make use of them, you can take each one of them. You can take this first part, which is 0C, and divide it into two halves, the 0 and the C. Each one of them will be called a nibble. So the 0 we have to convert it to to binary, which will be all zeros, and C will have to convert it to binary. How can I convert C to binary? By first knowing the value of C, and the value of C comes from the hexadecimal language, which is 0 1 2 3 4 5 6 7 8 8 9 A, B, C, D, E, and F. So A will be 10, B will be 11, C will be 12, D will be 13, E will be 14, and last one, F will be 15. So it's from 0 to 15 makes it 16 digit as hexadecimal language. So C here is 12. So you know 12, and how can I write 12 in binary? So 1 2 4 8 16 32 64 120. Okay, the guy here is not showing. 128. So how can I type 12? 12 can be written by by combining 4 and 8. So it will be 0 0 1 1 0 0 0 0. This is how we type. There will be 4 zeros, 1 1 1 0 0. So this is how C11 is represented in the binary, and 11 refers 12, and 12 represents C in the hexadecimal. So the first nibble will be 8 zeros, the second nibble will be this way, and then you'll have to retype them, all of them, or you can just like convert all the hexadecimal to the values without even converting them to the binary, just in the end to make the biggest value here, and the complete value of this MAC address and the complete value of this MAC address, and compare it. So you can do that, or you can just depend that A1 is smaller than AA, 19 is much smaller than BB. I have 1 and 9, and I have a double B, double 11, so it's 22. You can see that, okay? And B3 is a bit bigger than AA, because AA stands for double A's, okay? No, it will be even smaller, see? So AA stands for double A's, makes it 20, and B3 is B11 plus 3, 14. So this one is definitely small. So switch 4 will wins, okay? I hope that was clear for you. That was question 119. Question 1, I'm sleeping. Question 120, okay. And I was complaining IPv6, man, we have to see what the question is about. Drag and drop each broadcast IP address on the left to a column on the right. Not all the options are used. It says that whenever you found a broadcast address on the left, just drag it to the right. So on the right, only 4 broadcast addresses should be there. Okay, number 1 is 10.1.255.254. Is this guy a broadcast IP address or a valid or a network ID? Okay, since it's /24, just like we have talked about in chapter 1, back in chapter 1, /24 gives me 254 IP address, valid IP address, starting from .1 up to 254, and that makes .0 is a network ID, and .55, 255 or 255 is a broadcast ID. So this IP address is a valid IP address and it's not a broadcast IP address. Okay, so this one is not a broadcast. The other one will be 10.63.255.255/10. Okay, /10 means that the increment value will be, I can only imagine. You will use a lot of papers. Okay, let's do this together right now. So just in case you face it in the exam, you'll know what's happening and you will not waste a lot of time. So this will be 10.63.255.255. This is an IP address from somewhere, but just let's wait. If you want my advice, you can leave it for a few minutes and see those smaller subnet masks, solve them. You might figure all of the four IP addresses, the four answers from them, or you might find like three of them and the fourth one is completely incorrect, and that will make you sure that this one is a correct one. And this is a mechanism of not wasting time. So let's start with the smaller one. Smallest will be 29. Okay, so this will be 172.16.255 39/29. Gives me 29 ones, and thus this will be only three zeros in the three zeros left. So 2 to the power of 3 will be 8. 8 is the increment value of this subnet. And where does this subnet starts from? So this one is all ones. These are the network the network part. This is the host part. So an increment of 8 will be starting from 0, starting from 8, starting from 16, starting from 24. These are IDs. I'm using the increment value of 8 that I got from the number of zeros. So the first range will start from 0 with an increment value of 8. So it will be 0, 1, 2, 3, 4, 5, 6, 7. So 0 will be the network ID of this network. 7 will be the broadcast ID. 8 will be the next network ID. Increase 8, will jump to the next network ID. 16, 24, 32, and 40. 1 minute. So this IP address is from this range, from this guy actually, because this one starts with 32 with the increment value of 8 will be 32, 33, 34, 35, 36, 37, 38, 39. The eighth number will be 39, which is its broadcast address. So this one is a broadcast address definitely. Okay, so let's clear. Oh, I did not do that. I'm sorry. Yeah, there is an undo here. Yeah, okay. So we don't. Yeah, good. I did not really delete valuable information that much. Okay, remove these, remove these, remove these. Remove these guys. Okay. So we got this one. This one is definitely eliminated. This one is correct. So the other bigger one will be 25. So that will be 192, 168, 255, 127, and that will be /25. /25 gives me on the right how many zeros? I forgot. 8, 9, 9 zeros? No, there will be 7 zeros on the right. There will be 25 ones and 7 zeros to reach 32. So 2 to the power of 7 will be 2, 4, 8, 16, 32, 64, 128. So that will be 128. So this is the increment value. So the first one might be 1, because these are ones. These cannot be touched. How do I know? I know from subnetting from chapter 1. You must know that. 192, 168, 255. If it was .0, the first network of this octet, when it was 0, when the earth began creating, so that will be 192.168.255.0. The next will be an increment value of 128, so the next one will be 192.168.255.0. 128. So this is the network ID. This is the next network ID. What do I have? I have 127, which is only one step before the 128, which means that 127 is the broadcast ID of this network, this guy here. So you are also broadcast ID. Just come to me, please. Okay. Second one is found. Go ahead, go ahead, go ahead, go ahead, go ahead. Time is running. Okay. This one. This is a class C, a classic class C. So 192.168.110/24. It's a /24. So it starts from .0 and ends with .255. So this guy is a valid IP address and will never be a broadcast address. So you are eliminated. You are eliminated. How many were they? 1, 2, 3, 4, 5, 6. So there were 6 options. I need to fill only 4, and since these two are definitely not broadcast ID, then these two also should become broadcast IDs, broadcast addresses. Okay, so this is a mechanism, just like let me eliminate the 2 that are suspected or the 2 incorrect addresses, and I will choose the other 4 because you have time. Okay, you have time. And also, this is not a skill, this is also is a skill of troubleshooting. When you have like troubleshooting something in the network, and instead of having a big checklist of 10 steps, just eliminate the 2 unpredictable or 2 incorrect possibilities, and that's it. Run away. Okay, so the other 4 will be chosen. Only these 2 guys with the subnet mask of 24 will be incorrect. Okay, 1 to 1. We'll have only 4 questions left in this video. Refer to the exhibit. This is the exhibit. The exhibit says 4 routers connected together through a switch. Since there is a switch in the middle of some routers and those routers are using OSPF, this is a broadcast OSPF network. So all of the guys are inside area 0. Okay, so it's not a multi-area. Which 2 statements are true about the loopback addresses that are configured on router B? This is router B, and it has a loopback address of 10.0.0.1, 10.0.11, 10.0.21, 10.0.31. Each one of them is from a different address, from a different network. Okay, definitely. Let's see. A, it ensures that data will be forwarded by router B. Oh, I can see that. I got the question. Since there is a switch in the middle and it's an OSPF topology, then there will be broadcast network. It will be called an OSPF broadcast network. And in OSPF broadcast network, what will happen, just like we said in chapter 3, there will be elections to happen between routers to elect the designated router and a backup designated router. How to elect that? But the designated router will be the guy carrying the biggest IP address. I'm sorry, the biggest ID and the highest ID, and the highest ID is the highest IP address configured inside a router, or you can just configure OSPF router ID 1111 and that's it. So anyway, the point of forwarding is that the DR will be the one responsible for forwarding. So the DR from this topology should be the biggest loopback. You have a lot of zeros, not like these guys. Actually, this one is the biggest loopback address. So definitely router B will not be a DR because it doesn't have the biggest IP address, neither the biggest loopback. So it will not be you. It provides stability for the OSPF process on router B. Stability means that whenever ports are lost and the destination was the loopback, then any remaining up port will operate and continue receiving the packets to this loopback. So this might be correct. Let me leave it for a minute. C, it specifies that the router ID for router B should be 10.0.0.1. I know that the choosing the router ID automatically will be the highest configured IP address, but if there was a loopback, will the loopback win? Maybe. Why? Because loopbacks never goes down as long as the router is operating with its interface, one of its interfaces. So what I mean is that if depending on the interface's IP address, not the loopbacks, one of the guys was elected as a DR and that interface later on was down, then this router will lose its privilege of becoming a DR, a designated router. But if the loopbacks were to be chosen, or the loopbacks were to be the addresses responsible for electing a DR, then a loopback address will not go down because because as long as the router is up and running and it has at least one interface is up and running, then the loopback is reachable because it lies inside the router logically. So yes, it specifies that the router ID for router B should be 10.0. Yes, the ID for this guy will be 10.0.0.1. Okay, so this is an answer out of 2. It decreases the metric for routes that are no. Loopback have nothing to do with metrics. It's about port interfaces bandwidth. It indicates that RB should be elected as a DR. I'm sorry, no, it will not forward, it will not elect. So it's neither A or E. D is definitely incorrect. C is definitely correct. B, stability, because it will remain up and running forever as long as there are some interfaces up and running inside the device, some physical interfaces. Okay, question 122. Refer to the exhibit. The exhibit is port security, port status, port security enabled. The status is secure shutdown, violation mode, shutdown the default. This is a port security question. Which two statements about the interface that generated the output are true? We can see that before reading the options, the port security is enabled here, and the violation is the default of shutdown. You remember there was a violation, restrict, and there was a shutdown, restrict, and there was a discard, I believe, also. Okay, some aging time, aging type, secure static address aging, the maximum MAC address is accepted to. If there was a third MAC address to come, the port will go shut down. The total right now are 2. Any configured or sticky, no configured, but there is a sticky to MAC addresses, so any third guy will come will cause the port to shut down. Last source address, VLAN, no problem. Security violation count 1. This is a previous statistics. Okay, so one of these, let's see. 2 secure MAC addresses are manually configured. Actually, there is no configured, but there is a sticky. What's the difference between manual configured and sticky, since both of them are done by config, not automatic? Configured MAC addresses is where you type the MAC address yourself by typing the hexadecimal address. Sticky says that you just send the messenger to the next hop and say that please provide me with your MAC address in a bag. The messenger will go back and show you a label with the address, and you will remove the stick of the label and stick it, okay, or label it sticky, the same thing. So it's not manual, not that manual actually. The sticky difference, there is no manual MACs here, but this is sticky. These things have been elaborated more in chapter 5. A syslog message is generated when the maximum number of secure MAC addresses on the interface. Shutdown does not yeah, I believe shutdown does not generate syslog. Restrict, and there was also discard. Restrict does create syslog, discard does not. So shutdown also does not. The interface is error disabled right now. No, it did not receive a third one, and it's still working. Okay, the interface dynamically learned 2 source MAC address. It's not dynamic because it's a sticky, and this one differs. Okay, but all of those are incorrect. So I'm sorry, it's dynamic because you did not type the address statically. The address were delivered already from the opposite device by typing the command of sticky. So yes, it's dynamic. An Snmp trap is generated when the maximum number of secure MAC addresses is reached on the interface. SNMP trap, I believe this will always happen by default. The SNMP trap will always be generated by default once the SNMP is enabled already. So since A, B, and C are definitely incorrect, D is correct, yes, and E is a generic rule that will happen. Okay, so D and E will be correct for this question. 123. Refer to the exhibit. The exhibit is port security enabled violation protect. Oh, sorry, it was protect and restrict, not discard. Protect and restrict. Yes. So anyway, so this is another port security question. It says that which two statements about the interface generated are true? Okay, let's see the difference right now. The difference here is that the violation mode is different. Now it's protect, and protect is the one that. So we have protect and restrict. Protect and restrict. 1 minute, just 1 minute, because just to avoid causing you any confusing, whatever you say it. Let's go to the port security, and in the port security, shut down the port behavior. Okay, so there's a protect and restrict. Protect will do it silently without creating syslog. Restrict, it's not a strict. Restrict will create a syslog message. So we have protect, which the one that works silently. Okay, and drop a frame without logging it. Good, this is the difference. Aging time, aging type. The maximum R3. The total right now are 3, so threshold is reached. The configured is only 1, and 2 of them are sticky, so you see the difference right now, and no violation so far. So A, learned MAC addresses are deleted after 5 minutes of inactivity. What does the aging time does here? It does that the dynamically learned. Yes, that's correct. The dynamically learned will be deleted every aging time expiration. Yes. B. The interface is error disabled if packets arrive from a new unknown source address. It's not error disabled. The frame will be dropped silently because it's a protect, not a shutdown. C. It has dynamically learned to secure MAC addresses. Yes, sticky is considered as a dynamic learning, correct? D. It has dynamically learned 3 secure. No, 2 only, and the third one was static. Okay, this is a manual configure. E. The security violation counter increments if packet arrive from a new unknown source. Security violation counter if packet arrives from a new unknown source. I need to lab that. I'm not sure about it. Because protect will discard the frame silently without logging, but is it that silent? So even the violation will not work? This is half correct. I'm not sure about it. I need to lab it, and like in the lab we can do it and see if the count will increase, but since it's choose to and these two are definitely correct, then that's it. You can jump in. 124. Refer to the exhibit. The exhibit is also port security. Okay, no problem. This is also port security enabled. The violation is also protect. No timer, absolute. The maximum are 4. The learned are 3, so we still have 1 MAC address to be learned in the future. The configured is only 1. 2 of them are sticky, so 1 manual static and 2 dynamic. So the question says which 2 events occur on the interface if packets from an unknown source arrive after the interface learns the maximum number of the MAC addresses. So after the device learn the maximum number, which is 4, so after the 4th frame, the 4th MAC address, if a 5th frame comes, or a 5th packet, I'm sorry, even if it was a frame, it will include packet inside it. So if the 5th packet or a 5th frame comes, what will happen? A, the security violation counter does not increment or increase. This is this is what I was suspecting, because the last question was also protect. B, the LED turns off. No, because it's not a shutdown. C, the interface. This is also choose to. The interface is error disabled. No, it's not a shutdown. A syslog message is generated. No, it's not a restrict. E, the interface drop the traffic from the unknown. Definitely correct. And yes, this one is also correct. So for the last question, there was 3 correct answers. You have to choose 2 of them. I have choose the 2 I trust, and I believe if you choose any 2 out of these 3, the score will be the same according to the correction engine. It happens. It's just tricky things from Cisco. Okay, 125 will be, this will be our last question, I believe. Yes, finally. Okay, so 125 says refer to the exhibit, and the exhibit is a ton of routing entries in a routing table, big routing table that has B, which is BGP, DEX, which is external EIGRP, more BGP, more DEX, all the way to protocols that you have no idea about in CCNA. Okay, which 2 statements about the network environment of this router 1 must be true? Must be? Okay, A, there are 20 different network masks within 10.0.0.0/8. So the big guy here is 10.0.0.0/8, and inside it there is a 10/24, 10.2/24, 10.4/24, and this one is a 4th, 5th, 6th, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19. So within it there is another event 10 one, which is different for BGP. So yes, there are 20 entry for for this one. Yeah, it seems correct. This one seems correct. Okay, B, a static default route to default route. What is the default route? The last resort gateway is this guy, and it seems 10.85.33.14 was defined. Yeah, seems correct. Gateway of last resort is this guy to network 0000, which is the default route. It's an external EIGRP, so there is a redistribution that will happen between the default, the static default, and the EIGRP. 1 minute. C says 10 routes are equally load balanced between this interface and this interface. You're joking. This means that there are 10 routes in this routing table. All these 10 routes have 2 outbound interfaces. Okay, so for 10.0.1.0, it goes out of these 2 interfaces equally, the same metric. This is one. 10.0.2.0, the same thing, same metric, 2 interfaces different. So load balanced, and it's EIGRP. EIGRP does load balance by default, whether it was equal or non-equal, but it's talking about equal. So 2 so far. The third guy here also has 2 interfaces that are mentioned here with the same metric. The 4th, same thing. 5th, 6th, yeah. 7th, correct. 8th, yeah. 9th, and I have missed this guy. I did not, this one with the arrow I did not count because it does have, so this will makes it 10th. Or this guy is also coming outside of 2. 1 minute. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is the 9th, and this one, yeah, it's talking about a total routes, not a 10 dot something anything, but that has equally comes out of these guys interfaces. Yes, so this one is the 10th. Yep. C is correct. The 10.0.0.8, this one was learned via external EIGRP, external DEX. So 10.0.0/a, this is it. It was learned through BGP. Incorrect. And this one that I was suspecting actually so far is incorrect because choose two and both of them are correct. EIGRP AD was manually changed from 90 to 170. You know that I did mention a lot of times before that EIGRP, which is the D guy, has an AD of 90. All of the routing table here is not mentioning 90 at all. It's all mentioning 170. That was because the external EIGRP by default has the AD of 170. So it's not manually, it's automatically. The external EIGRP have an AD of 170. So this one is incorrect. These two are correct. This one maybe I did not catch it correct, but these two will be enough to pass the question, and that should be enough. We will have some redistribution and EIGRP and BGP in the CCNP Enterprise course. It will be a course that might take from me like 6 months to finish because I have to lab everything and like to do dozens of scenarios for each protocol. Why? Because the CCNP Enterprise core exam qualifies you for both the CCNP Enterprise and the CCIE Enterprise Infrastructure Lab exam. So you must not become a professional after the course ends. You must become a professional and half an expert. So yes, I will do my best, and I will definitely need a brand new laptop for that time. This guy is suffering right here because I'm using a lot of fans, cooling systems, but yet it's an old guy, it's 3 years old, so it will not be able to operate screen recorder with the pen, with PDFs, and then even G, which is the emulator that I will use in the CCNP. There will be no pack tracer there. Okay, so let's hope that I will be able to afford this laptop. Anyway, so this is the end of these questions. How many were they? I believe they were like 22 questions. Only this guy we did not answer. I did not answer because I'm not convinced with what it really wants. Let's hope that one of you will find out and will make a big benefit to all of us. Okay, so that should be enough for now, and I hope to see you in the upcoming video of the sixth part. Okay, and thanks a lot for watching. Goodbye.